Today I take the topic Physics Unit 2 Optics Scattering of Light. Scattering of light. What is mean by scattering of light? You see this topic. Okay. When sunlight enters the Earth atmosphere. When sunlight enters the Earth atmosphere, the atoms and the molecules of different gases, different gases present in the atmosphere, refract the light in all possible directions. This is called scattering of light. Okay. I explain. Earth, this area, atmosphere, this area, Earth atmosphere. The atmosphere inside atoms, molecules, different gases. Inside atoms, molecules, different gases. Okay. The sunlight enters the Earth atmosphere. Sunlight, incident ray, beam of light. Incident ray or beam of light. The sunlight enter the Earth atmosphere. The atom, molecules, different gases present in the Earth atmosphere refract. Refract of light in all possible directions. This is called scattering of light. These particles, atoms, molecules, different gases, these particles scatter. The sunlight enter the Earth atmosphere. The atom and molecules and different gases, present in the atmosphere refract the light in all possible directions. This is called scattering of light. The beam of light redirect in all directions, interact the particles. These particles also scatter. Atoms, molecules and different gases also scatter. Okay. Next, types of scattering. Okay. The scattering of light can be classified. Based on initial and final energy of the light beam. Based on the scattering of light can be classified. Okay. I will explain. Here, the sunlight pass the Earth atmosphere. The incident ray, beam of light the incident ray put on atom, molecule or different gases. This is scattered. Okay, the rays also scattering. Rays also scattering. This is also initial energy of the light beam. This is also final energy of the light beam. Initial energy of the light beam, final energy of the light beam, based on can be classified scattering of light. Okay. Two types. One also elastic scattering. Elastic scattering. Another also inelastic scattering. Another also inelastic scattering. Elastic scattering. What is meant by elastic scattering? Same. The energy of the incident beam of light. The energy of the incident beam of light. Okay, energy of the incident beam of light and the scattered beam of light. And the scattered beam of light. Scattered beam of light are same. Are same. This also elastic scattering. This also elastic scattering. Incidence beam of light. This also incidence beam of light. Incidence beam of light and scattered beam of light. Scattered beam of light. This is also scattered beam of light. Okay, this is also scattered beam of light. The incidence beam of light and the scattered beam of light same elastic scattering. Okay, and inelastic scattering. The energy of incident beam of light. The incidence beam of light. The energy of the incidence beam of light and the scattered beam of light. And the scattered beam of light. Not same. Not same. So, not same. It's also inelastic scattering. Explain. The incidence beam of light. The energy of incidence beam of light. The scattered beam of light. Scattered beam of light. This like not same. Not same inelastic scattering. Same incident beam of light and the scattered beam of light same also elastic scattering. Okay. The inelastic scattering classified nature and size based on nature and size. Nature and size based on can be classified elastic scattering, Rayleigh scattering, Rayleigh scattering, Rayleigh scattering, and next V scattering, V scattering, and next Tyndall scattering. Tyndall scattering. Tyndall scattering and next Raman scattering. Can be classified based on nature and size. Four types: Rayleigh scattering, Mie scattering, Tyndall scattering, Raman scattering. Recall types of scattering. Types of scattering. The types of scattering can be classified based on initial and final energy of the light beam. Initial and final energy of the light beam. Initial and final energy of the light beam can be classified based on types of scattering. Okay, and types of scattering. Two types. One also elastic scattering, another also inelastic scattering. One also elastic scattering, another also inelastic scattering. Elastic scattering. The energy of the incident beam of light and scattered beam of light are same. Is also elastic scattering. The energy of the incident beam of light, the scattered beam of light are same. Is also elastic scattering. The energy of the incident beam of light and the scattered beam of light not same. Also inelastic scattering. Elastic scattering and inelastic scattering classified. The scattering of light classified nature and size based on Rayleigh scattering, Mie scattering, Tyndall scattering, Raman scattering. Rayleigh scattering. The scattering of sunlight. The scattering of sunlight by the atoms or molecules of the gases in the Earth atmosphere is known as Rayleigh scattering. The scattering of sunlight by atoms or molecules of gases in the Earth atmosphere is known as Rayleigh scattering. As well, air, sunlight, okay, in particles, atom or molecule or different gases. The rays also scatter. This also Rayleigh scattering. As it's called scattering of Rayleigh scattering. Okay. The scattering of sunlight by atom or molecules of the gases in the Earth atmosphere is known as Rayleigh scattering. Okay. Rayleigh scattering law. Rayleigh scattering laws. Rayleigh scattering laws. The amount of scattering of light. The amount of scattering of light inversely proportional to fourth power of its wavelength. That is Rayleigh scattering of laws. The amount of scattering of light. Symbol. Amount of scattering of light. Symbol. Yes. The amount of scattering of light. Symbol. Yes. The amount of scattering of light. Inversely proportional. Okay. So inversely proportional. This symbol is also proportional symbol. So inversely proportional. 1 by fourth power of its wavelength. Wavelength symbol lambda. Power 4. Fourth power of its wavelength. That is Rayleigh scattering law. The amount of scattering of light inversely proportional to fourth power of its wavelength. That is Rayleigh scattering law. Simply yes, inversely proportional to 1 by lambda power 4. This is Rayleigh scattering law formula. The sky, you see the sky also blue color. Why the sky also blue color? Reasons. Totally different colors come in the sunlight. The sky also only you see the blue color only. This Rayleigh scattering law, reason for the sky also blue color. Reasons. Oh, the wavelength, the shorter wavelength more scattered compared to longer wavelength. Shorter wavelength more scattered compared to longer wavelength. According to this law, Rayleigh scattering of law. So this law, the scattering of light more scattered for shorter wavelength. Blue color is a shorter wavelength compared to red color. Red color, blue color. Blue color is a shorter wavelength. So the blue color totally scattered. So you see the sky blue color. Okay. But sunrise and sunset time. Sky also red color. Why? The sunrise and the sunset time compared to afternoon time, distance is very high. So the blue color, the shorter wavelength of the blue color totally scattered. So next red color least scattered. So you see the sunrise and sunset time, sky also red color. Okay, this sky also red color, sky also blue color. Reasons also Rayleigh scattering of law. Okay, we call Rayleigh scattering. The scattering of sunlight by atom or molecules of gases in the Earth atmosphere is known as Rayleigh scattering. So Rayleigh scattering law. The amount of scattering of light inversely proportional to fourth power of wavelength. According to this law, shorter wavelength more scattered and longer wavelength less scattered. So the sky blue color in daytime and sunrise sunset time, the sky also red color. Okay, next Mie scattering. Mie scattering take place when the diameter of the scatterer is similar to or larger than the wavelength of incident light. That is Mie scattering. Okay. The diameter of scatterer. Scatterer means atom or molecules or different gases. Atoms or molecules or different gases. This is scatterer. This scatterer diameter. For example, you want atom. The atom diameter is also diameter. Scatterer. Incident light, the incident ray of wavelength. Sun, the incident ray wavelength. Incident ray wavelength similar to or larger than the scatter of diameter of scatterer. This take place to form Mie scattering. We call Mie scattering take place when the diameter of the scatterer is similar to or larger than the wavelength of incident light. Incident light wavelength similar to or larger than diameter of scatterer. This take place form the Mie scattering. The Mie scattering, the cloud also white color. The reason is also Mie scattering. The Earth atmosphere, smoke, dust, water drops, other particles. These reasons also form the cloud also white color. The sunlight, white light to pass the Earth atmosphere. The Earth atmosphere water drops all color equal scattered. So the cloud also white color. So the cloud also is the white color. That is Mie scattering. Scattering. The scattering of light rays by colloidal particles in the colloid solution is called Tyndall scattering or Tyndall effect. The scattering of the light ray by the colloid particles in the colloid solution is called Tyndall scattering or Tyndall effect. For example, sun rays will enter the room through the window. Okay. The room inside air dust particles. Air dust particles scattered the beam of light. This is the example of Tyndall scattering. Tyndall scattering, the scattering of light rays by the colloidal particles in the colloid solution is called Tyndall scattering or Tyndall effect. Raman scattering. The interaction of light rays. The interaction of light rays with the particles of pure liquid or transparent solid. Pure liquids or transparent solid, which leads to change in wavelength or frequency. Which leads to change in wavelength or frequency. That is Raman scattering. That is Raman scattering. The interaction of light rays with the particles of pure liquid or transparent solid leads to change in wavelength or frequency. That is Raman scattering. I will explain. One beam of light or monochromatic light. Beam of light to pass any particles. The particles also gas or liquid, pure liquids or transparent solid. Transparent solid. The beam of light to pass the gas, different gases or pure liquids or transparent solid or scattered solids. These rays also scattered. Rays also scattered to form additional wavelength and frequency. More wavelength or frequency. More wavelength or frequency in incident ray of light, beam of light. Incident ray of light, wavelength or frequency. Incident rays or beam of light, wavelength or frequency very low compared to form a scattered light wavelength or frequency. This is also Raman scattering or Raman effect. Recall the interaction of light rays. The interaction, this point, interaction of light rays, the particles of pure liquid or transparent solid. Particles, gas or pure liquid or transparent solid. Leads to change in wavelength or frequency. More wavelength or frequency to form. This is Raman scattering or Raman effect. Rayleigh lines, Raman lines, Stokes lines and Stokes lines. Rayleigh lines, Raman lines, Stokes lines and Stokes lines. The spectral lines frequency equal to incidence ray frequency. Incidence ray sun, incidence ray frequency. Incidence ray frequency, scatterer, this also scatterer. These are also spectral lines. Spectral lines. Incidence ray frequency, spectral lines frequency. Spectral frequency equal Rayleigh lines. Equal Rayleigh lines. Incidence ray frequency more incidence ray frequency and spectral line frequency. The spectral line frequency is more. These lines are also Raman lines. The spectral line frequency is more compared to incidence ray frequency. And Stokes lines, the spectral line frequency is less incidence ray frequency. And the spectral line frequency is less compared to incidence ray frequency. That is Stokes lines and Stokes lines. The spectral line frequency is more. The spectral line frequency is more incidence ray frequency. That is anti-Stokes lines. Okay. Rayleigh lines, Raman scattering, Stokes lines and anti-Stokes. Okay, my dear students, today you see the topic scattering of light. Today you see the topic scattering of light and type of scattering. type of scattering, elastic scattering and inelastic scattering, and 4 types of scattering: Rayleigh scattering, Mean scattering, Tyndall scattering and Ramesh scattering. Thank you my dear student, to see this class.